stop the video and restart it. So now Carson is going to do this problem.
Okay.
Okay, so it looks like what he's doing, he's factored out the GCF of 16 from the first expression. And in the second expression, he's taking out a GCF.
Wait a minute. Hold up. Let me do that. 25x squared. Then
He's taking out a GCF of 25x squared.
what's left? Oh yeah, x minus 1.
So factoring what's under the radical, guys, is a really good way to start with these if you have polynomials or binomials. These are both binomials to start. Okay?
Okay, do I go?
Yep, keep going. The problem that I did, it was just monomial terms, so we could just immediately start simplifying. Are we listening?
Yes, I am.
Okay, so we could immediately start simplifying because there was no factoring involved. But in this case, these are binomial terms, so it is really important to try and factor them. Anything binomial, trinomial, or above, you need to try and factor before you simplify because you can't pull terms out when they're attached to plus and minus signs. Remember that just from the chapter on rationals where we couldn't cancel things out? Same thing here. Okay, all right, this looks great. So when he took out his GCFs, both of the GCFs were perfect squares. So he went ahead and took the square root of his perfect squares, which left him the same radical in both terms. He had the square root of x minus 1, which allowed him to combine the factors that had been taken out. 5x plus 4 becomes his new factor that's being multiplied by square root of x minus 1.
What's the dot?
I don't think it's supposed to be there. Oh, it's a multiplication? Yeah, you don't need that.
Okay.
I mean, it's not incorrect, but yeah, this dot right here is just saying that this is being multiplied by this. The parentheses and the radical give us the same information.
Yeah.
So it's kind of a redundant thing, but it's fine. Okay. Does that make sense?
Yes.
Okay,
It does make sense.
good deal.
The sentence is made.
The sense is made.
I want to do the next one.
Well, if we let Karen, we're gonna be here for like 3
Yes.
hours.
Yeah, that's why we should do it. I want to do it. As an experiment.
Ashley, come on.
Dang it.
Seriously, with the whining today.
Yeah. I just want to do it.
It's not a good day to record.
Sorry, John.
Actually, maybe it is a good day to record because you guys are so distracted that you're going to need to watch this tonight before you do your homework.
Oh,
All right, your problem is 5 square root of 2
So 5 square root
plus 3, and then it's one of those tall square roots because it says 1/2 underneath.
So it's all square root.
1/2. Okay.
It suddenly got dark.
Hey.
All right.
Go. Wait. So first.
So what do you think we need?
So they're not the same.
They're not the same radical.
So I need to figure out how to make them.
Okay. So let me give you some guidance here. First thing I would do is separate this into a single numerator and denominator so that you can really see what's in your numerator and what's in your denominator. So I would actually do 3, and 3 is a whole number, so it's going to go in the numerator, right? So I would do 3 times the square root of 1 up
Over
top
2.
over the square root of 2 down bottom.
This is Kenny. I'm sorry, it still didn't come through. Would you just like to tell it to me?
I sent an email. Did you get the email?
Did not get the email either.
Okay, we have 1 hot lunch, a chicken wrap with Italian for Ashley, and a salad with ranch for Lindsay.
Okay, chicken wrap Italian for Ashley Holland,
I have one.
Yes.
I have one.
and 1 hot lunch.
Mm-hmm.
And what was the other?
A salad with ranch for Lindsay.
Oh, I'm the one hot one.
Yeah.
Okay, thank you.
Okay,
Anyways.
and back to math. Because we didn't have enough distractions today. We needed more.
Alright.
All right,
And then
square root.
also
Yeah, if the 2 was under the square root to begin with, listen, it has to stay under the square root. Okay, now, if you were trying to add these 2 fractions, what would you need?
well, I need this to be
You need a denominator,
so.
right?
Oh, just put it over square root of 1, right?
But does that give you a common denominator?
No.
What do you need?
To pull the 2.
Well, right now it is over a 1, so show that it's over a 1.
Times it by square root.
Yes, absolutely. So guys, I don't know if you can hear us, what she's trying to do is she wants to be able to combine these, so she needs a common denominator. Right now, 5 square root of 2 is acting kind of like a whole number. It would be over a 1. So, but she wants it to be over square root of 2. So she's going to multiply that term by the square root of 2 over the square root of 2.
what you did there.
Mm-hmm.
Okay, so then. Right, so then I have 5 times the square root of 2, which is.
Move your hand down while you think so we can see.
Okay, so.
So we have square root of 2 times 5 times the square root of 2. So how would those combine?
Alright, so the square root of. So it'd be square root of 5. Because
5's not under the radical.
Alright, so.
5's outside. These two are under the radical, so they can be combined.
Alright, so.
So what is the square root of 2 times the square root of 2?
So 5 square root of 4.
Okay, and what's the square root of 4?
2.
And what's 5 times 2?
10. So this is 10.
Just 10. Yep,
10
up top.
Oh, I thought it would be,
See what happened there?
Yeah.
We had the square root of 2 times 5 times the square root of 2. So use the commutative property. You have 5 times the square root of 2 times the square root of 2. And we know from a previous unit that the square root of 2 times itself is just 2. 5 times 2 is 10. Mm-hmm. No, it's recording.
Alright, then. So I can't combine them yet because I can't. No,
Well, what is this one?
it's just
Right.
so I don't need it.
You don't need it.
Alright,
Exactly. Well, I mean, it's there.
But-
It's the square root of 1 is 1. Do you guys see that on the right?
Yes.
And then, so 3 times 1 is, right.
Alright, so then it's just 10.
This is one of the most complicated problems in the unit because you really have to think about a lot of different math that we know and then combine it with the new material.
Now I can combine them?
Yep.
Alright, so times 2.
Now we have two fractions with whole numbers up top and common denominators. She's going to combine them.
Now I have to,
And then
what's it called?
rationalize.
There you go.
Rationalize.
Thank you, Cameron. Rationalize the denominator.
So I times it by 2 over 2, right? Yeah,
Square root.
Square root.
Mhm.
So then, alright, so then I have square root of 2 times 2, which equals square root of 4, which is 2. And square root of 2 so 4 on the bottom, and then 13 times 1 is 13, because it's square root. No, square root. Ow!
Okay, two things. 13 times the square root of 2. Nothing goes in or out of the radical, so it's just 13 square root of 2. Okay, now down bottom you had square root of 2 times the square root of 2.
Which is square root of,
There you go. You forgot the radical. Yep. There we go. Okay, so final answer, 13 square root of 2 over 2. Any questions about that one?
That's the 13 by the way, guys. That's the 13.
13 square root of 2 over 2.
I'm sorry.
Yeah, rewrite the answer.
Okay, there you go. 13 square root of 2 over 2. We good?
No.
Yes, ma'am.
It's a good start. Okay, we'll stop there. That was section 11.6.